Hi, my name is Suresh. We will discuss today how data is converted into vectors. There are various types of data available. We need to convert each of the data types into vectors. So, what we need to understand initially, how data is being converted into data points and how data points are being converted into vectors. This is crucial in any data science project because there are many ways of converting different data types into vectors. Depending on project outcome, data has to be properly converted into data points to represent them into vectors. Data exists in many forms across different domains. Here we focus on 7 popular categories of data such as tabular data, text data, multimedia data, like image data, audio data and video data, also time series data and graph data. These categories have different processing techniques to represent them into vectors. Let us discuss tabular data. The tabular data comes with rows and columns. Each row of the table becomes a data point and columns are features of the data point. Each data point is transformed into a vector either by normalization on numeric data or applying encoding on categorical data. Each data point becomes a vector and it is represented as a point in vector space. In this example, Alice and Bob become two vectors and normalization is performed on both age and salary. This is a popular way to represent most of the problems in tabular data. This may not necessarily be a standard approach and it can change if the business problem is different. For example, if you want to predict employee salary hike for next year, then you want to convert the salary column data into time series based vector representation over monthly or yearly scale. Let us discuss text data, which are documents or articles. Text data consists of tokens called words or subwords. The unique tokens from all documents are called vocabulary. So in text representation, first you build a vocabulary. The traditional vector representation for text is called term frequency and inverse document frequency. In short, TF-IDF. It preserves statistical properties of word counts, weighted inversely if the same word appears across many documents, called inverse document frequency. If a word from vocabulary does not present in a document, that is represented as 0. But this technique has its own issues due to few words from a vocabulary for a short documents. This is called sparse representation of short documents, I would say. This has changed over time to learn semantic vectors for words that measures the meaning of the words. For example, king and queen has same distance as man and woman when they are represented in word embeddings. There are various approaches for word embeddings and they have been popularly used in text data for many machine learning problems. Let us talk about multimedia data. Multimedia data contains images, videos, and audio. And multimedia data requires specialized processing techniques and tools to convert data into vectors. An image is represented as pixel values organized into channels. A grayscale image contains a single channel whose values represent intensity levels of pixels. A color image contains 3 channels and each channel has intensity values corresponding to the red, green, blue components. Video data contains a sequence of images called frames. These frames are displayed one after another at a certain frame rate, creating the illusion of motion. Let us talk about image data, such as photos and scanned documents. Before analysis, filtering and pre-processing approaches can be applied to the raw pixel values to perform resizing, transformation, scaling, data standardization, and whitening. These steps help to normalize differences in image size, shape, orientation, and intensity, making these images more consistent and suitable for further processing or machine learning tasks. Then, high-level features in images are captured using other filters such as shapes, textures, and object parts. These high-level features can be represented as vectors for machine learning models. And deep learning frameworks such as convolution neural network can be used to extract these features directly from raw pixels in multiple stacked layers to the output predictions. Let us talk about video data representation. Since a video consists of a sequence of images, each image frame is first processed using filtering techniques on convolution neural networks CNN to extract image vectors. This sequence of image vectors from all frames is then aggregated using temporal pooling layers such as average pooling layer, max pooling layer, or temporal aggregation layers. Finally, the aggregated vector is flattened to produce a vector representation of the video, also called dense vector embeddings. Time series data is a sequence of values recorded over time. These features like trends, seasonality, and statistical measures are extracted from time sliding windows over each feature to form multi-dimensional vectors for modeling. For example, weather information such as temperature, wind over time is measured in a multi-dimensional vectors. Similarly, an audio waveform shows how sound changes over time, and it is split into small frames to extract features like pitch, energy, frequency, content. These frames' voice measurements are combined into multi-dimensional feature vectors, making the data suitable for analysis or machine learning models. Graph data, such as social media networks, has nodes and edges that represents entities and their relationships. To vectorize a graph, features from nodes, edges, and the overall structure such as node attributes, connectivity patterns, or graph embeddings are extended. Further, graph convolution networks extends traditional convolution neural networks to gather information from each node and its neighbors to capture the structure of the graph. These features are combined into multidimensional vectors, enabling the graph to be used in machine learning or network analysis tasks. Key takeaways and conclusions. Understanding various data types and their conversion into vectors is critical for effective machine learning. Once data is vectorized, it can be analyzed quantitatively to uncover patterns and drive decisions. Similarity or distance metrics can be computed in vector spaces, which provides measurable insights, allowing organization to extract value and actionable intelligence from diverse data sources.
Subscribe and leave a comment for more technical videos.